I think about 3 years ago it was that Intel we met with a number of, I think, key sort of developers and project managers and so on in Europe, and we asked them, why aren't you making your code parallel? So there are about 30 or so different large companies, and if I asked you to guess them, I'm sure you would. They're some of the main sort of developers of large applications that that you could buy off the shelf, as it were, and so on. And what we found there was that the number one stumbling block to writing parallel code or to getting code parallel was how to deal with legacy code. And much of the book, and I think much of the focus that Intel has done, has been around, this is the big challenge. This is we're in a situation where developers already have code, they have machines, they have equipment, but suddenly along comes these multi-core chips, and all our programs don't run in parallel. And so so the challenge that I've been for the developer is moving from non-parallel code to parallel code. So everything in the book, and the number one motivation, I think, in terms of parallel programming has been trying to make that step as obvious and easy as possible. Some of that is uncovered in the book. So I said earlier on that the book wasn't just about writing parallel code, but also about getting your code to be optimized. And in terms of producing optimized code, then a lot of time is spent on showing how to use the compiler to get vectorized code. So as you no doubt know, that one of the ways of getting not parallelism in terms of number of cores, but in terms of multiple calculations being done in one instruction, then these vectorization is the way that's done, and the compiler is capable of vectorizing code that you write. And so in the book we show how to get that optimization. It's a form of parallelism, but it's not parallelism as in on different cores. So, as you say, and as the technology goes forward, then you can be certain that the width of registers available in the sort of SIMD technology will get wider and wider. So, vectorizing code is important in order to have code that's going to take advantage of future generations of architecture. I think both kind of opportunities exist, and I meet developers that go both ways. So that there's a group of developers I meet that want to make their code parallel as easy as possible. They don't want to have any code re-engineering of significance. They'd like to introduce the parallelism as easy as possible. And Parallel Studio with support, for instance, for Silk Plus, helps to do that. There are, however, also developers whose first priority is performance, and that's all they're aiming for, and they don't care how they get it. So some people I'm working with will do some really technical, dirty things which break every programming sort of standard and so on. They care not about how they get to where they're going, and those people will more often than not. Well, first of all, they'll be aware of how the process is working and write code which is cache-friendly, for instance, or will be easy to vectorize. And they'll be quite happy to sit down and do some real deep analysis on what they're doing in order to get really optimized code. Now, what the book does and what the Parallel Studio does is it tries to bridge that gap, really, between doing nothing and doing everything, as it were. So for instance, using vectorization reports in the compiler will help programmers to more effectively lay out their code so it can be vectorized, take away some of the things that are stopping code from being vectorized. And then on the other hand, you get the programmer who simply wants to put, change their for loop so it becomes parallel. And so using Silk Plus or OpenMP are great ways for doing that. I haven't come across it in exactly the context you describe. I mean, what I have come across is lots of times is people who just don't understand the code that's in front of them. So, and if you remember, I said that one of the big problems about making code parallel is particularly how to accommodate legacy code. I mean, I remember a few years back, I was with a company helping them to work on some code, and in the middle of the code there was a comment that said, if anyone knows what, and then there was a swear word, this code is doing, please ring me on extension 247. and that's it's the first time I'd actually seen someone dare to write it in the code, but that I think, that most programmers that have inherited large code bases struggle to understand some of the detail. And it can become a block. So when it comes to analyzing code to make it parallel to do vectorization, then it's sometimes tough if you don't understand what the program's really doing. And so I'll give you an example. I've been working with a bank recently with one of the quant devs. They're developing code for doing risk analysis and so on. Much of the code was written in C++, but some of the more maths-oriented work was written in C. Because the particular person I was working with was very technical, he was able to look at the low level, what the C code was doing, and say, well, the way this is being done is not very clever, we ought to redo it. And together we worked at analyzing and recoding much of what was done. And often he used to say along the way, oh, well, these guys that have written the high-level stuff have not got a clue what the compiler's doing, have not got a clue what the processor's doing. And so together we worked to try and get, get code that would parallelize, I should say, and also vectorize. Now, in an ideal world, one should be able to do that without having to work hard at the code. I mean, the whole idea of the tools is to try and get the vectorization, the parallelization without too much effort. But as I say, when you've got legacy code, sometimes the problems are much more tough, and you have to really begin to shift things around to get any real benefit.